Sarah, you've touched on choosing the right algorithm, but now it seems we need a whole strategy. How do you actually approach a machine learning problem?
Exactly, Jane. It's not just about finding the algorithm. You have to think about the problem like a detective, considering the bigger picture.
So, it's like, first ask what kind of question?
Exactly. Explore the data, define what success means. Is it increased profit? Or reduced customer churn?
So, if you're a movie recommendation system, what does success look like?
Higher user engagement, more views, better movie ratings. It's not just about the algorithm. It's about the overall user experience.
Right, if you want to detect fraud, how do you measure success?
You'd look at the rate of false positives. How often does the system flag a transaction as fraudulent that isn't?
And if it's not financial, like predicting customer satisfaction, how do you quantify that?
Surveys, reviews, even social media data can give you an idea of satisfaction levels.
Wow. It's a lot more than just coding, it's problem solving.
Absolutely. You gotta be strategic, be practical. Think impact.
So, before you even write a line of code, you're already defining the scope.
You're assessing if the effort is worth it, if the problem actually matters. It's like a cost-benefit analysis.
Great point. So, it's a systematic way to think about these things.
It is, Jane. That's the key to effective machine learning.
And then what? A prototype, I guess.
Yep. Test out some potential solutions with a small representative data set.
That's a great framework, Sarah. Thanks.
You're welcome, Jane.
Sarah, so, we've talked about defining the problem and measuring success. Now, what's the practical process?
It's more of a cycle, Jane. Building a model is rarely a one-and-done thing. You build, test, and then
refine?
Exactly. Look at the model's errors. That reveals what data is missing, or if the task needs tweaking.
So, collect more data?
Potentially. Or adjust the problem itself. Maybe you need a different data point.
Makes sense. And then humans?
Sometimes a machine can get 90% of the way there.
So, we want to put humans in the loop for the tricky bits?
Yeah, imagine self-driving cars. The system might handle most situations, but
a pedestrian.
Yeah.
Exactly. Or medical diagnoses. AI can probably detect anomalies in scans, but a doctor confirms.
So, it's not AI versus human, it's AI plus human?
Exactly. Plus, a lot of systems don't need perfect accuracy.
Python is great for prototyping, but what about production?
Production often needs languages optimized for speed and scalability like Go or Java.
So you take your Python code and convert it?
Often, not necessarily reinventing the wheel, but optimizing the parts that need it for production.
That's key, finding the balance between speed and performance.
Plus, it's often different teams. Prototyping is about exploration, production is about reliability.
So, different languages for different roles.
Exactly.
So, you're saying iterative improvement is super valuable?
Definitely. It's not just building the perfect model. It's about continuously improving.
Thanks, Sarah.
You're welcome, Jane.
Sarah, so, we've talked about building, testing, and refining. Now, what about getting it out there?
Production, Jane. It's different.
Different how?
Less about flashy models, more about making sure the system works reliably.
You mean like?
Simplicity. Think of it like building a house. A beautiful, complex design might look great on paper, but if the foundations are shoddy, it's about evaluating the complexity of each step.
So, avoid over-engineering?
Exactly. Each part of the pipeline needs to be robust. If your data changes or your server hiccups, can it handle it?
Sounds technical.
It is. Plus, there's technical debt. It's like adding features without considering the long-term maintenance.
Like a credit card,
Yeah, it feels good for a while, but it's easy to get into a difficult financial position.
So once the model's good, test it live?
Exactly. A/B testing is key.
What's that?
You show part of your user's one version algorithm A, and the other part, another version algorithm B.
To see which works better?
Exactly. Track the results on key metrics.
And compare algorithms A and B?
Yep. A is often a new model, B is the old way.
So, it's not just about accuracy, it's about user experience too?
Absolutely. Recommendations that throw off a website's traffic. It's about what users do, not just whether the algorithm works.
How do we avoid introducing technical debt in the first place?
Careful design, prototyping, and iterative improvement.
Thanks, Sarah.
You're welcome, Jane.
So, Sarah, we've talked about making sure our models work in production and online testing. Now, what if the data we need to process, well, isn't quite ready for off-the-shelf solutions?
Exactly, Jane. Sometimes you need a custom tool. Think of Scikit-learn as a great toolbox, but sometimes you need a specialized tool for a very specific job.
Like what?
Imagine processing financial data where specific calculations are crucial. Some pre-processing steps might require custom functions beyond what Scikit-learn offers.
So, how do we build this special tool?
We build our own estimator within the Scikit-learn framework.
Sounds complicated.
Not really, the Scikit-learn interface makes it easy. It's a bit like creating a new toolbox with pre-built handles and a fitting slot.
Aha, I see. How does this work?
You use specific classes to build your custom functions. It's really elegant.
Show me.
Okay, imagine transforming data by adding one to each element.
That's very basic.
Yes, but a very useful example. You inherit from the base Scikit-learn classes, and you implement the key functions.
Can you show me some code?
Yes, like creating a transformer that takes data and increases it by 1.
Okay.
From a user perspective, you just use it like any other Scikit-learn tool.
That's much less intimidating.
It's a lot like creating new recipes for your kitchen, Jane. Some recipes are great for every occasion. Others only work for a very particular situation.
So, custom estimators aren't always necessary?
Not always. You should consider using Scikit-learn's built-in tools first. If they don't fit, custom code could help.
It makes sense.
Exactly. It's a great balance between reusable tools and custom, specific solutions.
Thanks, Sarah.
You're welcome, Jane.
So, Sarah, we've covered building custom tools, which is awesome. But what if you want to really dig into the why behind these algorithms, beyond the practical how?
Exactly, Jane. There's a whole world of theory, probability, linear algebra, and optimization underpinning these impressive algorithms. It's like building the very foundation of our machine learning knowledge.
So, are we talking about really heavy-duty math here?
Well, it depends on your goals, you know. You don't need to be a math whiz to be a fantastic machine learning practitioner, but it can absolutely help. Think of it like cooking. You can follow a recipe perfectly without understanding the chemistry of the ingredients, but knowing that gives you a deeper appreciation and control of the outcome.
I get that. What kinds of resources can we use to delve deeper into these theories?
Lots of great books. Hands-on Machine Learning with Scikit-learn, Keras and TensorFlow by Aurélien Gérin is fantastic. It's really practical and doesn't shy away from the mathematical concepts, walking you through them nicely. Also, if you want something even more focused on the theoretical side, you might look at Pattern Recognition and Machine Learning by Christopher Bishop. It's more dense but thorough and really dives deep into the theory.
Hands-on sounds approachable.
It is. It bridges the gap between practice and theory, which I think is incredibly useful. Personally, I like to start with the practical, then layer on the theory as I need it.
Interesting. And how does this translate back into building models?
Understanding the theory gives you a sense of what's possible, and you can tailor your model design to better suit the specific problem. You can think of theory as the engine, the practical applications as the gears, and custom solutions as the tools that put it all together.
That makes a lot of sense. So learning the theory is about understanding the bigger picture.
Exactly. You see the intricate patterns and interconnections.
Thanks, Sarah. This has been really insightful.
You're welcome, Jane. It's been a pleasure sharing these perspectives.
Listeners, don't forget to subscribe to the podcast for more episodes packed with exciting machine learning discussions. We delve into the practical, the theoretical, and the everything in between.
I highly recommend checking out the resources we've discussed today. And keep in touch.
Thanks again, Sarah. Great insights today.
Likewise, Jane. Take care, everyone.
Bye-bye.